It is important that this video be done as an amendment to a video that was posted um, earlier. Um, we have to take into consideration that um, the reactions RA and RB are not at the end of the beam, and so therefore the approach for for this workout would be much different. All right. Now, of course, we have already converted. We have converted our UDLs to point load. We have converted the UDLs to point load, and this now would be our equivalent free body diagram. Over here, we have our load line. Over here, we have our load line, and it is already scaled, right? So I'm using 1 kilonewton, 5 millimeters to represent 1 kilonewton, right? So if we have 60 here, then 60 divided by 5 would be 12. So the distance right here is 12. And let me just show what's going on. So this here is 12. All right. This here will be 33. And this here would be 16. All right. So over here we have our scaled load line. And of course we know that this over here will be our polar polygon. So over there is our polar polygon. Now the approach to this is that we would copy AO, and at a point convenient, let me just use X right here. So at a point convenient, then OA will be on that line there. Next, we will have BO, and BO will be copied there. Now what you realize is that BO comes and meet the force, the downward force here, and we are then going to get CO, and CO will come and touch this force here. Then we have DO, and DO will be there. All right, so that is where this will be DO. Now what we're going to do is we're going to extend DO. We're going to extend DO, and DO will now come and touch RB. Where DO touch RB, we're interested in this point. We're interested in this point. Let me put a point there. And we are also going to extend AO, oh, so this point miss. All right, that point missed right there. So let us quickly do this over. Copy. So we are right there. And BO, CO, right there. So we see that this one miss. Get rid of that. and we get our DO. Get our DO right there. All right. So as we say, we extend. Good. So let's move this point right there. All right. And we're now going to extend OA. So we extend OA and we have a point right here. Now, notice now, where the extension of OA touches RA right here, and where the extension of OD touches RB right here, then we are going to connect these 2 points. So we are going to connect from here to there. Now once we connect that, let me change this. Now once we connect this line there, all right, we are going to copy this. And once we copy from here to there at the center of the polar polygon, we extend EX. We extend. Now we are going to now measure what the distance is or what the length is of what the magnitude is of RA. So this would be RA, and from here to D would be our RB. So RA would be equal to 18 times 5, because remember we had scaled it. So this would be equal to 90. All right. So this will be equal to 90 kilonewtons. All right. And let me just copy this. RB would be equal to 43 times 5, which would give us 215 kilonewtons. All right. Now we know, let me put this up here. We know that RA plus RB should be equal to 305 kilonewtons. Should be equal to 305 kilonewtons, because once we add 60, 165, and 80, we should get 305 kilonewtons. So as is, 90 plus 215 gives us 305 kilonewtons. So this is how we solve. This is how we solve for the reactions RA and RB, given that the reactions are not at the end of the beam. All right.